All right, we're going to start. Are you ready? Let's talk about the quiz. I think today you are not ready for the quiz, right? And the quiz is not to be told. It will pop up whenever I want. When I think we should have the quiz. And the first quiz content doesn't need to be the same as last year. It will be something that I think you can do it. Okay? And I think any one of you who come to class should be on time, should be able to do it. Okay? Update. Class material. I upload the quiz solution of last year on the blackboard. Okay? But that is last year quiz. Let's go over it quickly. Who want to volunteer to answer any of this? Or I have the prize. I have the prize if you want to volunteer. It is a printout of the lecture note. No one want to have it? It's in color. Okay, and I have big 4 per page. And some of you cannot print it like this. No one want to have it? Volunteer. Who want to volunteer? No one? You print out everything already? Or what? Well, let me read it. So the unit that I have, heat capacity BTU per pound Fahrenheit. Of course, this was asked last year, and this was closed book. Okay. Joule per kilogram Kelvin. Anyone haven't memorized that yet? So everyone memorized it already, right? And we have, yes. And we have unit of thermal conductivity in English and in SI, overall heat transfer coefficient, unit. I just asked about the unit. Gas contract, water vapor shall not be more than 7. What unit? Rad per year actually. For single pass coil, line heater, choke should be placed before or after the line heater. You know that, right? It has to be after. H2S, consideration of 10 ppm. Read it, okay? And this is a calculation. If you can do this, I hope that you can do this year quiz. It may be on this Thursday, or may not be on this Thursday. I don't tell you, okay? Okay, next thing is about how many of you missed first day of class or first day of class with university? Everyone have university excuse. Raise your hand. 1, 2, 3, 4, 5. Oh, more than about 10. So you may miss the talk. Did you watch the video? Did you miss and you watch the video? Okay. So I have a question. If I know about any academic misconduct, what do I do? What did I promise you that I will do? What's your name? I have this. Okay, you want it? Okay. What do I promise that I will do for the case of academic misconduct? What do I do? Is there any particular number that I will call? Do I tell your dad or something? Or I call? No. If there's an academic misconduct happen, what do I do? What is my promise to you? I will tell office of what? Student something? Office of Student Conduct. Okay, that's what I promise that I will do. Solution for homework number 1. Okay, for those of you who missed the first day of class, like 10 plus people, we have just 80 people, so 1/8 of the people. If you haven't listened to it, please go back and open the video and listen to that. Okay, the homework has 2 parts, right? The part that is about writing, we don't give you the solution, okay? But you should know. 300 word essay about academic integrity. Essay must describe the impact of academic integrity value on the following item. Who finished this one already? You ready to get a gift? Who finished this? Hey, Tolani, give the rest for those who raised their hand, okay? Okay, what's your answer?
Oh,
So who raised their hand? Who want the gift? Give it to them, Tolani, okay?
yeah. So if I participate in academic misconduct, well, I might not learn the information, and then I might get a job, maybe, and then I'll get fired because I don't know what I need to do because I cheated. But I could hurt somebody.
Oh.
Yeah, because my design was messed up or something like that.
What's the question be impact others today?
Well, the same thing could happen to them, I suppose.
Impact them at university.
It looks bad on them. So, like, if an employer notices that, like, a bunch of students they employ from a particular university, like, don't know what they need to know, well, then they'll be like, well, we're not going to go back over there because they suck.
Okay. What about ethics for engineers?
Whoa. We're going to miss D?
Transform publicly on your organization. If we don't do anything like ethics, what happens to the organization?
Yeah, like if we don't follow the fundamental canons of ethics, well then me and the progress of my work are going to suffer because, as stated before, I might get somebody hurt or, might not design something correctly, and it's important to always keep the public's safety and health as a first priority. So, like, if I don't follow those, and I design something that doesn't have the public safety in mind, I get somebody hurt.
Is this important?
Yeah, it's super important. Thank you. I don't feel like I did a very good job.
You may take his answer, okay, or create your own.
With citations.
A good citation, okay. I emphasize more about this because some of you miss a class, okay, just that. And impact for yourself. Let's say I cheat on my dissertation. My dissertation will be on university library for the rest of my life, right? Even if one find out later, what happened to me? So will they take my degree back? Could be, depending on how much part that I copy from somebody else, right? So it may work right now, but in the long run, it doesn't work. What if I just make up all the data and what if I make up all my resume? Do you want me to teach you? Everything in my resume is fake. What do you feel about me? So let's say nobody find out, but after a while, one of you find out. What do? You will fire me, right? You don't want that to happen. So it may help you just right now, but in the long run, it won't be good. And the impact on myself, if I ever lie about my dissertation, what happened to me right away is I have to create two sets of reality. So one is a fake one is a real one, right? And if I keep doing that a lot, I may not know which one is real because I lie too often. You get it? So if I lie about something, if you small, the big thing start from a small thing. So if I start doing something bad from the small thing, it keep growing. So I think every one of you have lied at one point in time in your life. So we should stop. Okay, at least during your work, or in your dissertation, or in your senior project, or somewhere. If I lie too much, I won't trust myself. Okay, and I will not know which one is real, which one is fake, because I'm doing that too much. And somebody else can lie to me, and I just believe that. Somebody else can fool me very easy, because I don't know which one is real if I lie too much. And what go around will come around back later. So even though you can get away, like right now, later on it will have severe impact. Okay, if I fake everything about my resume, it can get me a job here, but when I get caught, I will get fired, right? And won't get any job anymore. So, and this have impact to society, and I think you should have more than 100 words for sure, right? You can do this part, but here, this part is a solution. Make your part. Number 2, I think that's more on ethics. Go to the website and read it. I cannot take too much time on this, okay? Question? Yes.
A lot of them do overlap, like, I don't know, like a lot of them, these kind of.
Write it again until you have 300 words.
Oh, great.
Yeah, the number of words matter. So by writing it, this tell me you read it, or you know it, or you get it from somewhere, okay? You have to write about it. The rest, I think you can do it. This thing, more material about the class. Last year material does not need to be available to you, okay? But I make it available to everyone, including you, everyone in the world, not just you. So I upload like this is course material of 2015 and 16. This is agric.blogspot.com. So this link comes from my profile page on TTU website. When you go in, you have 2015 prelim course book, prelim open book, exam 1, exam 2, 2016 agric part exam. Of course, there is another part of the exam that was not given out. Heat transfer problem, blah, separator. You can go through all this material, okay, and have it. Doesn't mean that you cheat or anything. Not like at the class that if you have the old homework or exam, you will get into trouble. Not this one. I upload it, and if you who interested in this, or you want check it, you can check it. 2015 exam is not 2018, right? 2015 is the exam is old. It's old exam. It won't be the same. But if you can do that one, I think you can do this one too. But hopefully, okay, hopefully. Memorizing is learning. That's what I think. Is it? Memorizing one way of learning. If you memorize something, and you don't want to talk. Karim, Osama, Abdel Majid, Abdelaziz, Al-Kawanki. Hi, Karim. Memorizing, is that one way of learning? Or memorizing is not learning?
If you understand what you are memorizing.
Memorizing. When I memorize the material, for example, I go to O exam, I memorize everything. Is that one way of learning? Really? That's not learning? If machine do it, it's not quite memorizing, because they cannot do something else other than the set that it was used to train the machine. But you are not machine, right? When you look at it, you memorize, then you can think about something else. You can do some kind of extrapolation, right? If you memorize all this material, I think you can do the new exam. The new exam, even though it's not the same, but if you memorize the old exam, the number of questions, the number of possible questions I can make, it is limited. Okay? It's just that much. I don't have infinite number of questions to ask you. If you do all, you can do this one too. Okay? But I don't think you will do all. It's a lot. I don't do all either. And material keep changing over here. Okay, that's all about. Hey, Tolani, can I have a pen? I don't have a pen. That's all about the class material. Question? No question? Yes, question. Are you going to get those material in the blackboard? This material is not on the blackboard. This is in my website, available for free of charge for everyone who go into my website. Thank you. And my website, there's a link from TT website profile page, or you can do egrid.blogspot.com, where you just type my name, Egrid Panadimswat. You get this. It has the material for other courses that I taught, like numerical method in Python, multi-phase flow in Py, flow assurance, another multi-phase flow, and C++, whatever you want to do. I don't worry that you know too much about our exam. That's the point. You know how to do it. And I promise you the new exam, it will be as hard as it should. It won't be too hard. Okay? The old exam of 2017 will be in the blackboard. Only that. But previous year, it's just in here. And I don't promise you to upload it. I just put it in here. Video lecture, you can Google my name on YouTube, and you will have previous lecture. We have last year facility class, numerical method, multi-phase flow, blah 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 blah. Okay, if you are interested in, but you should not, because you come to class, right? Who missed the class already? Tolani, how many students do we have in this room?
I haven't counted it.
Oh, count it. Yeah. All right. Today, other than tell you about homework solution and about all exam, all quiz, we will try to finish the gas density, the hydrate part. And next time, if we have quiz, and if you cannot do it, it's on you, okay? I'm not responsible for that. And are you going to be ready for the next quiz? If you have on Thursday? Oh, tomorrow, when you go to the lab, bring safety glass. Who don't know when to go to the lab tomorrow? If you don't know, come to see me after class. Okay, there are 3 sessions, and you should enroll in 1 to 150, 2 to 250, and 4 to 450 or something. If you don't know which session to go to the lab, come to see me after class. Who download the Silva's textbook already? None of you? Did you all download the Silva's textbook? Come on. William W. Esther. Did you download the material from the website? Silva's textbook. Why not? Do you know where it is? You didn't do it? Paul E. Everett. Did you download the material? Yes. Did you? Is it good? Yeah. Ivan Garcia. Did you download the material from the blackboard? You will, right? At least the quiz, right? Okay. All right. Let's finish this one. So about hydrate, we prevent it by put the lime heater. One thing to mention about choking. We can choke a little bit on the wellhead. Okay? On the wellhead itself, like what you see outdoor over here, we can choke it, but not too much. So when we choke it at the wellhead, we will have some pressure drop. So when we have pressure drop, we can use the thinner pipe, okay? Lower pressure rating pipe. So we can choke it at the wellhead. The reason that we don't want to choke it too much at the wellhead is we don't want to form hydrate. So we choke a little bit at the wellhead, and we will choke more later on. Okay? And before we choke a lot, we put what? Lime heater, right? So that's why one of the questions of last year is about the location of lime heater. That's it. For single pass coil lime heater, the choke should be placed after the line heater. Okay? Mr. Bulat, would you like to add something more on stroking at the wellhead, engineering ethics for those who miss, or you're fine? Okay, let's continue. Log mean temperature difference. Okay, today we will try to cover every calculation of line heater. For log mean temperature difference, I did not give you the derivation. The derivation, there's a derivation based on the heat balance, but at the end, this is what you get. Anyone get curious on how do we get this? No? No one? After you get the price, then you don't stop raising your hand or what? There's the derivation for that. If you want to know more, we will talk. But basically, here's the formula. Log mean temperature difference. Greatest difference minus lowest difference divided by natural log of that ratio. I think 4 years ago, there's a student asked me, what is the difference between Ln and Log? Do you know that? Brandon L. Gillespie. Hi Brandon, what is the difference between Ln and Log? Both are log. Log is log based what? Which one is natural log? Yes. Everyone should know, right? But I got the question during the exam. Okay, what I tell him is, I don't tell you anything anymore. So you should know that. Okay. This slide and the next slide, the difference is the location of arrow. Previous slide is concurrent. We flow everything in the same direction. Next slide is counter current. We flow it in the opposite direction. Take a look at the formula. The formula stay the same or change? Okay. Is it the same? Yes, it is. The formula works whether you put it in the opposite direction or in the same direction. Okay, the formula stay the same. So you can use the log mean temperature difference, regardless whether you flow counter current or concurrent. After we know the enthalpy difference, the enthalpy difference comes from the chart, right, that you have. That's the enthalpy difference. After we know the enthalpy difference, we can calculate BTU per hour, given that we know the flow rate. So let's say we know, hey, gas flow rate is 3 million standard cubic foot per day. Enthalpy difference is 1000 BTU per pound mole. I multiply by 109.9, then I get heat required per BTU. This equation means that if we flow faster, we need more heat. Okay? If we flow faster, we need more heat. Or if we require more enthalpy change, we need more heat. Oh, one more thing that I upload is the larger version on the blackboard. You will see larger version of GPS book. Oh, here's a GPS book where the chart comes from. 2 of them, $100. Okay. It's a book where the chart comes from, and we don't have any. I didn't upload it yet. It's a larger version of the graph. I want to show you the bigger one.
it's not fun.
For methane, it looks like this, right? Very big. Methane pressure enthalpy diagram. The one that I showed you in the slide is kind of small. So if you use this one, we have pressure over here, constant temperature line, the S curve. The one here is 0 Fahrenheit, and on the left is minus sign, minus something. On the right is bigger. So we have this curve, and if we have this axis is the enthalpy. If we have a constant enthalpy when we flow through a shock, we just drop like that, right? And then we can read temperature pressure. On this part, I think this is the area of two-phase, I think phase envelope. Okay, the actual charge is bigger. Okay, and when you go work, if you need it, your employer may provide it for you, or just buy it. $100, is it? Or maybe more. Okay. And once we, from the chart, we get that the edge, right? And G is just how fast we flow. If we require same BTU per pound, if we require the same BTU per pound more, but we flow faster means more pound more per hour, right? So if we flow faster, we need more heat. Matthew J. Green model. How do we get 109.9? Where does that come from? What is that for? No clue. Who do you want to help you? Do you want to point a finger? Who do you want to call? Who? What's his name? Levi. Where's Levi? Levi get a gift already. Let us come. V08, middle name J, last name Hansberger.
Yeah.
How do you pronounce your name?
Void.
Void. Where's 109 come from? 109.9. Where does that come from?
Is that constant?
To do what?
Convert?
Unit conversion?
Conversion constant?
Yes, it is. 109.9 is just unit conversion. If you notice, left hand side BTU per hour, that's the unit of left hand side, right? What about right hand side? G is mmSCFD. H is BTU per pound mole. The unit of left hand side and right hand side, they must be the same. But if you use just this, they're not the same. So that's why we need some kind of unit conversion factor. If not last year, the year before last year, one of my questions is, I'm asking about how do we get 109.9? Please derive. And if you don't get 109.9, you don't get much score. Okay, this is like calculation part. Any clue on Kai Harrington? Hi Kai. How do we get 109.9? How do we do calculation? Can you tell me the procedure to get 109.9?
You cancel out pound per mole and SCF, so like BTU per day and per day.
So you know how to do it? Maybe. One of the senior professor told me, senior student, they don't need to know anything anymore about unit conversion. Do you want me to explain about it, or we should skip? And just ask you in the exam and you will be able to do it automatically. Okay, Kai, If I ask you just in the exam, will you be able to do it automatically? No? Okay, let's talk about it more. Alright, the trick is we need to start something with the same, we put the unit in. Okay, the step to get 109.9, we write the equation, and over here, G is, I put power mole per hour. Okay. In this formula, G is mmSCFD. I don't care. G is what? Volumetric flow rate, right? No, it's not quite volumetric flow rate. Even though it's mmSCFD, it's more like mass flow rate. Do you know why? Because it has this S, standard condition. So million cubic foot at the standard condition will be a certain power, correct? It can be mass flow rate. It is a volume flow rate at the standard condition is the same as the mass flow rate. You can calculate mass flow rate based on that. That is why I put G as power mole per hour. So I start with that. So G has power mole per hour. H BTU per power mole, so that the unit cancel, and on the right hand side I have BTU per hour, and on the left hand side I have BTU per hour. So we start the equation with a unit consistent parameter. Then I try to put something that I want. Hey, if I don't want per hour, but I want per day, what do you do? So I know that it should be hour, right? And one day has 24 hours. So if I put it in power mole per day, I have to multiply by 24. So that this and this, they are the same. Make sense? And next step, I have to know what is the relationship between power mole and million standard cubic foot. How many power mole equal to 1 million standard cubic foot? I start with PV equal to ZNRT. At the standard condition, compressibility factor or Z equal to what? Say out loud with confidence that you're from Texas Tech. Z equal to 1. Yeah. Alright. So the standard condition that I use are these. Then R constant and standard condition temperature in Röntgen unit. I get that. Pay attention here. R value, gas constant. There are several gas constants used. For example, 8.3, 8,300 or something, 1.7 something, or 10.7 something. How do you select? You select the one that the unit has something to do with what you are deriving. So you want it in the unit of power mole. So gas constant need to have something to do with power mole, right? And it has to have Röntgen. In the test, if I give you several gas constants, I hope you can select the right one. Okay, there are several gas constants and it can be in several units, right? Alright, 1 power mole at the standard condition, Z equal to 1, I can P equal to what? 14.73, temperature equal to about 520, I put the number in, then I can know 1 power mole equal to that much cubic foot. You did this in high school, did you? Already. So once I know that, then instead of put power mole per day, I don't want to put power mole per day. I want to put the unit that I like. I put standard cubic foot. But I know that 1 standard cubic foot is not the same as 1 power mole. So I want 1 power mole, right? So I put the standard cubic foot in. I have to divide by about 380 so that I get, so that everything stays the same. So I have, if I put standard cubic foot, I divide it by 380, it becomes power mole. So I don't change anything in the equation. So it's still good. Then, okay, from here to here, I don't like standard cubic foot. I want 1 million standard cubic foot. So if I, instead of 1 million, I put just number 1. So I have 1 million standard cubic foot. If I put on the top equation, I put 1 and 60. If I put over here, I put just number 1. So I missed by 60. I have to multiply 60 later. Okay, so this is to make everything stay the same. One common mistake, not from you but from previous year student, is they do something similar to this. Exactly the same, except they flip everything. Instead of 1 million on the top, they put on the bottom. Instead of 24 on the bottom, they put on the top. Instead of this on the bottom, they put on the top. They flip everything, and the answer is, of course, wrong. They won't get 109, they get something else too. So you may think that this is very easy, and it is easy, but please practice, okay? Because if you flip everything and your answer is wrong, you get 0. I will be happy to do so. I'll give you 0, nothing else. So practice. By doing that, I get 110, not quite 109, but it's close enough, okay? Kai, now can you do it? Can you do similar unit conversion? I'll ask you later. Okay, there are several more. Heat duty. So after we know amount of heat required, so based on the change in enthalpy, the change in enthalpy tells us it's from the molecular diagram, right? From the chart. And G is the flow rate. When we calculate total heat, maximum amount of gas, water, and condensate must be considered. We may not just have gas, we may have oil, we may have water, okay, and we may have heat loss, okay. Special operation conditions such as startup or a shut-in valve may require temporary heat. So we need to know what we are doing. Some operation may need heat a little bit. We need to consider heat loss. Heat loss depends on how fast is the wind. If the wind blow very fast, we have more heat loss. If we don't have insulation layer, we have more heat loss. Okay. If the ambient temperature is very cold, we have more heat loss. But we are not going to be able to know. Every day the temperature change continuously, right? So that's why we have this formula. Heat loss, we can say, hey, 10% of the heat requirement for gas, oil, and water. So we approximate it like that. So heat loss, we can just say, hey, it's 10%. That's a suggestion from civil textbook. Okay, once we know the heat required, then we can do more calculation on the fire tube size. We use this number, 10,000 BTU per hour per square foot, to approximate the area of fire tube required. Okay. Area of fire tube required, we can use this formula. Fire tube length equal to that number multiplied by Q over D BTU per hour and fire tube in inch. Fire tube diameter in inch. Where does this number come from, Kai? Yeah, it's unit conversion plus a little bit more, I think. So Q is BTU per hour, right? Did I show that? Yes. So Q is BTU per hour. How come we have? So length multiplied by diameter give me what? Kind of area, right? But it's not quite area because we have cylinder shape like this. So the area on this part is not just L multiplied by D, it's something else. Let's briefly take a look at the derivation. So I have heat flux, small q, is heat flux is heat per unit, amount of heat per unit time per unit area. It's a heat flux. So Q, which is BTU per hour, divided by area. Area of surface on this side of the cylinder is what? Pi. So the circumference is pi d multiplied by L. But diameter, we use the unit of inch, so we have to divide it by 12. Okay? So this is the surface area. Heat per time per unit area equal to heat flux. That's what it is. We assume that the heat flux of the fire tube is 10,000. If we put 10,000 over there, we do the math, we get that number. Okay? So that number didn't just pop up out of nowhere. There's some reason behind it. And I think after we finish this, then I will tell you why do we have to worry too much about derivation and all calculation. So now you can calculate the length, right? The length of the fire tube. Okay. We know what kind of tube diameter that we are going to use. Pressure drop can be a problem. You remember the picture? This picture. We have several of the coil. What should be the size? How big should it be? Suleiman Hasanov. So if I have a big pipe and small pipe, which one is more expensive, Suleiman? More expensive. Small or big? Small pipe is more expensive than the big pipe. Would you like to change your answer a little bit? Being opposite. If I give you very small pipe and I give you a big pipe will be more expensive because it has more material, right? It's a lot more difficult to make. So I won't ask this question in the exam, but I think you should know big pipe is more expensive than small pipe. The reason that we have to have a bigger pipe is to reduce the pressure drop and have slow movement, not too slow but slow enough of gas inside so that we can prevent erosion. We don't want the velocity inside the pipe to exceed the erosional velocity. So if we make it big, it has the same volumetric flow rate, then it will be slower. Okay? And big pipe is more expensive than small pipe. Okay. So we have to take a look at the pressure drop consideration. We have to take a look at erosional flow, erosional velocity. We don't want, if we have a little bit of some particle inside and it moves too fast, it can erode the pipe, right? So we need to tell the size, we need to calculate the pressure drop. And of course, it links to this length, okay? And also the pressure rating. The pressure rating for the pipe, for this coil, should be rated for the maximum pressure that you can have in your system, which is the well shut-in pressure. Okay, you still remember, right? So the pressure rating will tell us about how thick should be the pipe. Should it be schedule 40? Should it be schedule 80 or what? Okay, here's the calculation procedure. Number one, to select the line heater, we check the hydrate temperature. Decide if cast iron coil are needed or steel pipe coil are okay. Do we use indirect heater or what? What do we do? Or we don't even need to put heater. If your gas is already hot, it's in summer, we may not put line heater. We may put line heater later on. Okay. So indirect heater can be placed in flow line ahead of free water knockout to assist the separation tool. You can heat it up a little bit to enhance the separation. And we need to check for steel coil for gas or use cast iron coil for oil, water. So if we have just gas, just use steel coil. So, but if we have oil or water in it, we may use cast iron so that we don't have the problem of corrosion. Okay. The second step, so the first step is just check height curve and the pipe material that we should use, and you can check the pressure rating. Okay, pressure rating. Second step is calculate the firebox rating BTU per hour. 109.9 multiplied by G multiplied by delta H is this one, right? And then we get L equal to something something. Check the coil pressure rating. Do the erosional velocity check. Check the pressure drop in the coil. Pressure drop in the coil should be 5 to 20 psi, not more than that. If it's a lot lower than 5, this means the pipe may be too big, too expensive, but it works anyway. Get U value from figure 3, then calculate the coil area, set by temperature equal to 100 Fahrenheit, do the selection. That's a figure 3. Figure 3. Figure 3. This one. So this is overall film coefficient. Let's show you the example because I just tell you small part of many things. Let's put them together. How do we do any of this? Okay. Silver textbook, page 6. Okay. We don't reach the example yet. Okay. This is a pressure drop of high pressure gas coil. They give the formula. Delta P is the pressure drop in pin side A. P1 inlet pressure, P2 outlet pressure, LE equivalent length of pipe from table 5 or 7. This term P1 square minus P2 square come from figure 5. So basically, typically when we do pressure drop in the pipe calculation, first thing we calculate Reynolds number, right? From Reynolds number, we know if it is turbulent or laminar. Then we calculate friction factor, whether we use the Moody diagram or we just do 64 over Reynolds number. Then we can calculate frictional pressure loss, 12 V square over D. That's the pressure drop in the pipe. And we calculate pressure drop due to elevation, pressure drop due to any bend, any joint. Did you study this? You did already many times, right? Okay. For the case of gas, when we have pressure drop, the temperature change, correct? When temperature change, density change. Reynolds number is what? Hayden A H E R R E. What is the formula for Reynolds number?